So the next thing we're going to look at is second normal form. So in order for second normal form to be valid, you first of all must have done first normal form. So a table is in second normal form if it's also in first normal form. The second part of second normal form is every non-key attribute is fully functionally dependent on the primary key. Now, two things about this. Now, first of all, when you're defining this in the exam, you need to include both parts. So first of all, that it's in first normal form, and also that it's every non-key attribute is fully function dependent. The same goes for third normal form. So third normal form is in second normal form and also transitive dependency. Now the reason for that is because there's normally 2 marks for it. So 1 mark for saying it is in first normal form, second mark for the other part. That's really good because if you can't remember the exact detail of fully functionally dependent, then as long as you remember the first bit, you get half marks, which is job done, isn't it? So, what do we mean by fully functionally dependent? Now, I've included the result of first normal form on this slide just to show you our starting point. So, as we kind of picked up in the last kind of video, there are still some issues with this table. So, if we kind of maybe look at some of these issues, you can see that the product is repeated multiple times. Okay, so that is a problem, isn't it? It shouldn't be repeated because that's breaking some of the initial principles of normalisation. So we've got that update anomaly kind of idea. So we need to fix that, and that's where second normal form really kicks in. So let's explore this idea of fully functionally dependent. Now, let's consider an order. Now, if I make an order, it's going to be made up of products. So if I go onto Amazon, I type in, I don't know, trainers or whatever I want to buy, my order is going to be made up of those products, isn't it? Okay, so I place my order, pay for my order, and then eventually the product will arrive. The order cannot exist without a product because that makes no sense. I can't order nothing, can't I? So I must have a product as part of my order. However, when the product arrives, it's completely separate, isn't it? It's something physical and tangible that I can touch and I can use. So although they're very closely linked, and there is definitely some dependency on those because you can't have an order without a product, they're not the same, are they? They are separate still. Think back to the first video I did when I was explaining what is an entity. I said, well, you can have physical items, which are non-living, such as a pair of trainers, and you could also have an idea, a concept like an order. Okay, so those are 2 separate ideas. So they're not fully dependent on each other. Okay, we call it a partial dependency. Okay, they've got that partial, so you can't have an order without a product, but they're not the same, but they're definitely dependent. Okay, that's why we use the word partial for this. Let's really drill into those words because in order to understand second normal form, we have to understand these words a bit more clearly. So a related is where there's a link between 2 entities. So they are separate entities and there's a relationship between them. Partial dependency, which is essentially what first normal form is doing, the field can only be contained with the entity, but not only dependent on the primary key. Okay, so what does that mean? It means it's dependent on something other than the primary key. Okay, and we'll explore that one in a second. Full dependencies, the field is dependent on the primary key and nothing else. Okay, so this is what we're looking for. Is an attribute dependent on only the primary key, or is it dependent on something else? Okay, partial dependency is where it's dependent on something else other than the primary key, so i.e. it's dependent on more than one thing. And fully functional dependent is when it's only ever dependent on that primary key. That's the key difference between them. So partial, 1 or more attributes it's dependent on. Full, only 1. Let's see this in action. So the order and the product, okay, they have a partial dependency, okay, because if you think about product, so you've got the product name, so frisbee, and that's dependent on the order, yes, because you can't have an order without a product. However, it's also dependent on the product ID, isn't it? Yeah, so each product has its own product ID. So there's 2 dependencies there. Okay, so we can't have that in first normal form, ergo we can split it up. So that's the reason why we split this. So Remember, whenever we do any normal form, the solution to it is we spot where the problem is. We then figure out what the entities are going to be. We figure out what attributes goes in which entity, what the primary keys are and whether I need to introduce them, what my foreign keys are, and bang, I've got my answer. So that's what I've done here. So the two entities we need is the order itself and the product, okay, which is why we've got the order table here underlined and the product here. Then we work out what goes with which. Well, the order has to keep the customer ID because the customer places an order. That's definitely dependent on that one, that you can't split that up. I'll come back to product ID in a moment. The product name definitely goes with the product itself, and the supplier was definitely going with the product, isn't it? Now, the eagle eye amongst you will probably also notice that there's a little bit of an issue here with supply because I've got some duplication here. You are correct, but guess what? That's third normal form time. Okay, so we'll ignore that one for the moment. But notice that the duplication on the product has now gone. We only have each product in there once. Now we have to introduce a foreign key because there's a link between it, because a product can be placed in many different orders. So two people will order frisbees, for example, okay, which is why the foreign key is in the product table. So that's what's happened here, okay. We have identified the problem, okay, this idea that products and orders are not fully functionally dependent on each other. We've split them up into two tables, product and order. We've worked out what goes with which. We've worked out the prime keys. We've worked out our foreign keys. Job done. That's the solution. So let's have a look at this table now. So there's a lot of problems with this database. Okay, so pause the video for now and have a look through this and see if you can work out what the issues are. Okay, so first of all, hopefully you've noticed that we have got some duplications here. Okay, we got the same as we got an attribute with multiple, a cell with multiple values in it. So aggregate data, ergo not in first normal form. So that needs to be fixed, doesn't it? So we fixed that. So remember when we fix something, we split it in two. So we had child and present. Okay. Now a child can have potentially many presents, and a present could be given to many different children. What we mean by that is not that each child gets the same present, kind of share it. It's more a case of we might have two children getting the same thing, but separate items. So for example, two children might get a toy car. So we have a many-to-many link. Now, second order form fixes this because there is a problem there. We can't have a many-to-many link because actually, where do we put the foreign keys? We put the foreign keys on the main side, but we've got too many sides now, so that is hard to do. So when we have this situation, where we have many-to-many, we have to obviously do another step, which means creating a brand new table. So remember, whenever we have a problem with normalization as an issue that we've spotted, we just create more tables. Okay. Now, in this table, it's a special table. It's called a linking table. Okay. So we're going to create a linking table, which is going to sit bang in the middle here. Okay. And then we're going to link them together. So let's see that in action. So we create a linking table, and that linking table essentially stores the foreign key. So it's effectively describing the relationship between those two tables. Okay, it's describing that main-to-many link. So a child can have many presents, the present can have many children. So we represent that with a brand new table which contains the two foreign keys. So let's look at the actual attributes now. So you can see the child present has the two foreign keys. Now I've just made that a composite primary. Okay, so although these are the foreign keys from child and present, I put them together, made a composite primary, which is very common for linking tables. Okay, I could, if I wish to, introduce a brand new primary key. That is up to you. Okay, it actually makes no difference when you're answering exam questions which one you choose. They will give you marks for both approaches. So let's look at this problem now. So normalize this into second normal form. Now, first of all, I want you to realize straight away this is not in first normal form yet. So we've got fix first normal form as well, and then do second normal form. Now, this problem, I think some students find it difficult to kind of visualize it. So let me explain the data a little bit first, and then you can have a go at it. Okay, so what this database is showing is essentially people renting properties. Okay, so we've got John K here, and what he's done is he's rented 2 properties. Now, what this really means is, okay, I can move house, can't I? So I might rent one property, so 6 Lawrence Street, okay, live there for a little bit, and then I move, okay, and I move to a brand new property and I move in there. Now that property I originally came from is now free for someone else to rent, okay, which is why we've got Aline Stewart here, who is now renting the exact same property, okay, as John K, and the difference is they rented it at different time. So as it turns out, Aline's rented it before John did. Okay, and then you can see also Aline has also rented out the PG16 property, the 5 Novara Drive. So they both got the same property, rented the same property, but at different times. Okay, so what this database is showing is a property that has been rented, and the rent itself is an idea, okay, a rental contract. I can rent something for a certain amount of time, and for anybody, I mean, you guys are probably too young to rent your own properties yet, but you know, a property won't be rented to one person, then the landlord, because he's a lovely, delightful person, or she's a lovely, delightful person, puts the price up because they want to make more money, and they charge someone a different price. And again, that's normal, but each rental agreement will have a property that is linked with a time it's linked with, so what the date range, and also how much you're renting. Okay, I want to make that nice and clear because that will help you understand how to normalize this data. Okay, so pause the video now, have a go normalizing it to second normal form. Last hint I'll give you is there is a many-to-many link in here. Have a go. And here's the answer to that question. So as you can see, there's 4 tables being produced. Well, how do we get there? Well, first of all, it's quite clear that we've got aggregate data here. So property and customer, well, that has to come out straight away. So we create the customer table and the property table. Okay, so that's where those 2 come out. And also, you notice there is also kind of aggregate data on the owner as well, so that can come out as well. So you end up with customer, property, and owners. Remember, sometimes during normalization we might end up with 3 tables instead of 2. So that gives us the customer table, and it gives us the owner table and the property. Now we have this issue with rent. Well, where does rent go? Now initially we might put the rent with the customer, but because the customer might rent it, but then we get all this duplication of information, which isn't what we want. Therefore, we create a rental thing, because a customer can rent a property, okay, and can rent many properties, and a property can be rented by many customers, okay, because we've got that when it's many, which is where the rental comes in. Now, the reason why this question is really useful is because sometimes when you create a linking table, some students will just think, okay, well, the linking table, yeah, okay, that's fixing many-to-many links, brilliant. Well, I know I've got to put the 2 foreign keys in there, which is the customer number and the property number in this case, brilliant, okay, done. But sometimes that link is also described by more information. So remember, it's the description of how 2 things link together. Okay, sometimes that is just literally they are linked together, but sometimes that link has more description. Okay, so in this case, a customer is renting a property. Okay, so the relationship between customer and property is a rent, and that rent has information. It has the start and end date of the rent and how much they're paying. Okay, which is why the rental table here contains extra information. So that is just kind of something to bear in mind, that if you've got some fields which don't seem to go into any of the tables that you've created, it may be that they go into the linking table you've created. Okay, so if you've got a main to main link, sometimes that will happen. Okay, hopefully that makes sense. So now's a good opportunity to make some notes in second normal form. Again, I've included some examples here for you to go through. So please do have a look at that. Those are lots of videos. So the first one is showing how to fix many-to-many links, and it's a very common question in the exam. And as it turns out, the answer is pretty much the same each time. And also, there's another example there for you to have a look at for second normal form. So finally, here is another database. See if you can try and normalize it again. So again, it's not in first normal form yet. Can you get it to second normal form following the rules? So here's the answer to that question. So again, because we've got multiple values on item and customers, we need to split those two out into client and items. Okay, that makes sense, doesn't it? The client is going to have the name and address. Okay, that makes sense because that's definitely fully dependent on clients. The item is obviously going to have item name because that makes sense. However, then we got this idea of bids. Now, a client can make many bids on an item. Okay, an item can be have lots of different customers, clients bid on it. Okay, so for example, I might have an item that I bid for, that someone else bids for it, then I bid for it again, and we get that kind of thing going. So it's a many-to-many link, isn't it? So when you've got a many-to-many link, you create a linking table, which is what this bid table is doing. And because we have a bid amount, well, that is not dependent on the client. Okay, yep, the client is paying the money for it, but it's not fully dependent on that client. It's dependent on the bid itself, and it's not dependent on the item. So although I'm spending that money to buy the item, it again is not dependent. Therefore, the bid amount goes into the bid table. Now in this example, I've got bid ID. So instead of using a composite primary key, I'm actually using that as a primary key as well. So a linking table does not have to use a composite primary key. So this is another example of that. So the reason I'm giving this example is just to show that slight change in it, so you are familiar with it, so it doesn't catch you out. So hopefully all that makes sense. Do practice second normal form, because if you don't get second normal form, third normal form will really find it hard. So spend the time, do the research, understand how I'm getting to the answers, and see how you get on.